This is the code that we're going to use for this activity. What this will do is when we move our board, it will show different NeoPixels, different colors and different positions. To start with, we have an include. This will add the Adafruit Circuit Playground library to our file. This means that we can then use some specialist functions that they've already pre-written for us. It makes the code a lot easier. We then define 3 different floats. Because they're all floats, these variables can all be defined on the same line. We can define them separately if you wish. That's fine too. But for now, we'll define them all on one line because they're all floats. We then have a define, which is a move threshold. You can change this up to the value 10, but the lower the number, the more sensitive this will be. So if you find that as you move your board, it's reacting too quickly or too much, then you can just make it less sensitive. So that's where you will change the value there. We then have our void setup, which we've seen in all the other sketches that we've used so far. We'll always see a setup and a loop. But in this case, the setup, we've only got 2 things to set up, nice and easy. We're going to do our serial, and we're going to use this rate of 9600. This means that when we come up to use our serial monitor, that we'll see the code displayed in the monitor area. So this is initializing that serial monitor. We then make an instance of Circuit Playground, and this is what we're going to be doing. So we're going to use begin, which is predefined in the Circuit Playground library. From there, we'll go to our loop, and in the loop, first of all, we'll just clear the pixels, make sure nothing's on. We then take these 3 values of floats that we have earlier, and we're going to give it a value. So in order to do that, we're going to say that this float is going to have the value of Circuit Playground X motion. Okay, so that's one type of motion. Y will have the motion Y value, and Z will have the motion Z value. Okay, so these will all be numerical values. This bit of code here is just making a calculation. Now, there's a little bit of mathematics involved. That's not my specialty as such, but what we're going to do is use this to create the calculations to get the movement that we're after. So this code has been pre-written. And just this bit here is where it will display on our serial monitor. It will display that stored vector value, so we can see it. There's then going to be a very small delay. So if you remember, delay 1000 was for 1 second. So this is a very short delay just to let that process happen. We'll then get the data. So getting the data is taking this float value and we're saying, let's allocate it this value. So it will grab all 3 values and it'll create a new vector value for us. Then what we're going to do here is we're going to say if there is some movement, okay? So this starts this little if process. So if there is some movement, we want it to do this. So what we'd like it to do, I've used a little for loop here. So we're going to say x is going to be 0. This is a small x, it's going to be 0, and it's an integer. And we're going to say if it's not 10, so if the value is less than 10, we're going to keep doing this. So we're going to do this sequence for 10 times. And what we're doing here is we're allocating random values because I'd like it to have different color lights and different positions. So the value for the red, for the green, and for the blue will be equal to this random function up to number 255, which is the value it can hold. So it will choose this function here, random, will choose any number up to 255. And that will put it into this set pixel color function. So we're going to have a random value for the red, the green, and the blue. Okay. Then what we're going to do is we're going to give it a little bit of a delay as well, just to let these colors take hold. We've also done here a random position. There's 10 possible positions because there's 10 NeoPixels on that board. So we're saying give it a random position. Now, when I tested this, although it was random, I liked to have it so it also altered the number of NeoPixels that were sparkling. So I decided to change the value of X over here. So instead of it always being 0, it was going to take the random position and use that. So if the position was 6, for example, it will start at 6, which means only 4 will be lit in the next loop. It will do this 4 times. So this way it also creates another little random variable happening there. Once this has all been executed, we've got here another little delay just so we can see the effects of what's happening. Now you can play around with the different delays and see how it affects your board and how it affects the effect that you're after. Okay, as was suggested, this could be maybe put on some kind of glove, and when you wave, you get these lovely NeoPixels lighting up. So what we're going to do is we're going to head over to the upload command, and we're going to upload this to our board. So make sure your board is plugged in. As you can see, mine is plugged in, the green light is on, and I've pre-selected my board and my port. So always make sure your board and port has been selected. Okay, now I'm going to go ahead and upload this, and I'm just going to look at the output window while that happens. So we'll just move that up. Okay, so you should have similar messages. The upload is complete, and it means now this is running on our board. So if we have a look at moving this board, we can now see that we've got these lovely NeoPixels that light up for us based on how we're moving the board. So hopefully that will work for you. You should see the same types of effects. Have a play around with the number of delays or how it's delayed, or you don't have to make it random colors, for example. You can alter your code and stipulate the exact colors that you want. So all you would do is change those values here. So you could actually say what color you would like, and that will alter the color on the board. So that's the tutorial, that's the code, and that is the working circuit playground. Thank you.